Hey everyone, welcome to my channel. In this video, we will create a coronavirus predictor that will predict the total number of cases based on the previous data that has been provided. So before we actually begin, let me show you the results. So here we have the code, and if I run this, it is going to give us a plot. Here we have the best fit line. You can see the purple line is basically our original data, and the blue line is the best fit line, and the red dot over here is the prediction. So if we close this and we move on to our console, you can see that here the accuracy is 99.92%, and we also have the prediction after 2 days, and the prediction is basically 23.1 million. So the data I have used is, as you can see, it's up till 19th of August, and today is 22nd of August. So we will count the day of 20th and 21st. 22nd we will not count because the data is still to come. Before it was 22.15, and our prediction is that it will be 23.1 after 2 days. So let's go and check the live update. So it is in fact 23.1, and this is 22nd of August. So if I refresh this is not a screenshot. So here you can see it's 23.14. So as you can see, the prediction is quite accurate. So we will be creating this model, and I will go step by step on how to create this. But before we start, I would like to share the disclaimer that this is purely an educational video related to machine learning. It has no medical advice related to coronavirus, and the dataset used here is from one source, and the data might vary from other sources. So let's get started. So here we are in the PyCharm environment, and this is the same folder or the same directory that we have used for our previous projects. So the libraries are already installed. So if you want to, you can go and install it in the settings, and you can add here all the libraries required. For example, pandas, and we have scikit-learn, and then we have numpy, we have matplotlib. So, and the rest of them, they will install automatically. So you can go one by one and install them if you have not been following through the series. Okay. So then we have this corona predictor.py file, and then we have the cases file here. So if I open this up, it's simply IDs and the cases for each day. So the starting day, let me check what was the starting day. So if we go till top here, so this is the starting day. So it's 31st of December. So that was the starting day, and from there up till now it has been 234 days. So this is the data we have up to 22.15 million. So this data set I have taken from this source, which is ourworldindata.org. So this is the coronavirus source data by Hannah Ritchie. I'm pretty sure I pronounced it wrong. Anyways, so this is the source, and here is the file that I downloaded, total confirmed cases. So when you download it, it might be a little bit different because it will be updated. But if you want to follow along with the dataset that I have used, I will put the link of this in the description or on the website so you can download. Okay, so before we begin, let's talk about the type of model that we are going to create. So earlier we tried on linear regression, and then we tried on multilinear regression, and both of the cases we have linear data. This means that if one variable is increasing, the other one will increase as well. Like if the area of the house is increasing, the price of the house will increase as well. So this is basically linear relationship. Now we also have sometimes non-linear relationship where the data is not always increasing with the same ratio as the other variable. So in that case, we have already seen what polynomial functions are. If you don't know about polynomial functions, you can check out the video that I posted earlier that explains all about what you call polynomial functions. But here I have googled polynomial equation, and I will just give a quick recap. So a linear equation will have ax plus b, but a quadratic equation, which is basically your second order polynomial equation, it will have a square, and it will be x squared and bx, and then a cubic equation or third order polynomial will be cube and then squared and then x. Now one thing to note here is that multilinear regression and polynomial or nonlinear regression is a little bit confusing. So in multilinear regression, basically we have m1 x1, then m2 x2, m3 x3. So here x is basically a feature that is different from x2. So x1 is different than x2, x2 is different than x3. For example, x1 is the area of the house, then x2 is the number of bedrooms, x3 is the parking space. So all of these are different. Now the thing with polynomial regression is that this x is basically the same. It's a single feature. It's not different. So it is repeating. The only difference is that we are creating our own feature with it. So we are creating our own feature by squaring it. And here we are creating our own feature by first of all using cube, and then we are squaring it, and then this is the actual feature. So x squared and x3 is what we are producing ourselves. It is not an actual feature we are creating ourselves. But in the case of multilinear regression, all of these are actual features that are provided before we actually start. So this is something which is a little bit confusing between multilinear regression and polynomial regression. So that being said, let's go back to our model. So here we are going to start off by importing. So we will import pandas and then as pd, and then we are going to load in our data. So we are going to say load data, and here we are going to write data is equals to pd.read csv, and the CSV file we have here, so we can simply write and it should give us the name. And then we can write that our separation is basically a comma, because these are comma separated values, CSV, that's why we are putting a comma. Then we will write data is equals to data, and we are going to specify which columns we are talking about. In this case we simply have ID and cases, so it's not a big deal, but usually we have a lot of them, so we have to define. So we are going to write this anyway, and then we will write let's print the head. So we will print the data.head, and this will give us the information. So let's print that out, and there we have. So we have the ID and we have the cases, and should we put some, okay, let's put something at the top. We are going to write here print, and we want to print dashes, and we want to multiply it by 30, and then we are going to print, we will call it head, and then we will write print and dash again multiplied by 30. So if we run this now, there you go. So we get a nice heading, and then we have our head. Okay, so this is good so far. Now we will prepare our data before we actually send it. So we will write here prepare data, and let's do one thing. We will copy this and we will paste here, and we will call this prepare data. Okay, so what kind of preparation do we have to do? Now the preparation is actually fairly simple. First of all, we have to convert these into numpy arrays. So we will write x is equals to, this is our feature, so we will write np.array, and we have data, and we want the id. So this is our feature, and then we will write dot reshape, and we will say -1 and 1. So this is something that is required by the machine learning library, and we did not import numpy, so we will write here import numpy as np, and then we are going to copy this, and we will write here the same thing, except for this will be cases and this will be y. So now would be a good time to actually plot this and see how it looks like. So we will say import matplotlib.pyplot as plt, and over here we will say plt.plot, and we want to plot y. And do we need to give any specifications? Let's put a purple color, so magenta. So let's run that. Oh yeah, we need to add the plt.show. So let's run it again, and there we have it. So this is our data. We could put an asterisk and it would show all the points, but I think it will be too much. Yeah, it's too much. Maybe we can just zoom in. Still, it's too much. Zoom in a little bit. Yeah, so here you can see each of the plots that we are getting, each of the points, but again it's too much, so I'm going to remove that. Okay, so the next step is to actually create our features. So as you know, a polynomial regression or a polynomial equation with second order or higher, it will have multiple features. So it will have x, then x squared, then x cubed, then x to the power of 4. Whatever that is, it will need a separate table. So we will need a new column. So right now we have only one column. So we have only id. So we need the square of id, we need the cube of id. So these will be our more features, further features that we will use. So to create this, we can use the functionality within our scikit-learn library. So we can write here from sklearn imports, let's say, it's in preprocessing imports polynomial features. Yes. So we are going to create an object here. So let's write this poly feature is equals to, let's say, polynomial features, and here we have to define the number of degrees. So if we put 2, that will be x squared and x only. And then if we put 3, then it will be x cubed and x squared and x. So I will show you what this means. So we can write here x is equals to poly feature dot fit and fit transform, and then we have to transform x. So what this will do is it will take this x, which was only 1 2 3 4, only one column, and it will add more columns to it, so that we have these other features. So let me print this out so you can understand. Let's print x.head. Let's print that. No, it's converted, so it might not work. So this is not a data frame anymore. Okay, so let's print x as it is. Hopefully it will show us. Yeah, it does. Okay, so here you can see It goes really far. Okay, so here you can see that we have 1, and then we have 1 squared, then we have 2, then we have 2 squared, then 3, then 3 squared, and then so on. So if I put let's say 3 degrees, then it will add another column in which we will have the cubes. So if I go back up, you can see here 2, then 4, and then 8, then 3 and 9, and then 27. So this is how it works. So we will keep it at 2, and that should be good. So this is pretty much what we need for pre-processing our data, and now we can just send it to our model for training. Now the thing is that we are not going to split the data because we already don't have a lot of data. It's just 200 values. So in this rare case, we are going to push it as much as we can to train as good as possible. So let's start the training. So we will write here training data, and we will write it here, and then we are going to print this, and we will say training data. So next we are going to create our model, which is basically linear model. I think we didn't import, so let's import that here. So we are going to say that from scikit-learn from scikit-learn import linear model. Yes, so this is what we will use. So we will say here linear underscore model, and we will say dot linear regression, and then we will simply say model dot fit, and that will be x and y. So then we can check the accuracy of it. Accuracy is equals to model dot score, and we will put x and y, and that should give us our accuracy. And then we can print accuracy, and then we will round this off because it will be in decimal places, so we want to control how many decimal places we want. So we will multiply it by 100, and then we will say 3 decimal places is what we need. Then we will add a percentage, and we will end it. What is happening here? Okay, I should not put this, my bad, and this should be a bracket. I mixed 2 things together, so yeah, so that should also not be here. Okay, so next step, we are going to run this. So let's run this and see what happens. And there we have it. So we are getting 99.492% accuracy, which is not bad at all. And so what we can do now is we can actually plot this and see how it looks like. So we can use the prediction method. So we can write here y, let's say 0, and then we can say that model.predict, and we want it to predict all the values of x. So once it predicts, we can actually plot these values. So here we can say plt dot plot, and again we want to plot y0, and let's give it a different color, and we will, because this is an estimate, we will give it a dashed line, and we will say plt dot show, and we will go up and we will remove the show over here because we want both of them to be on the same plot. So let's run this, and there we have it. So now we can see that it is trying to create a best fit line by using a single curvature, and you can see that it's not fitting very well. Over here we have some gaps, over here we have some gaps, here we have some huge gaps. So a second order equation is not enough because it has only one curve in this case. So what we can do is we can go up, and where is it? Yeah, here we can simply write 3 degrees. So this will allow it to have 2 curves. So if we run this, and right away you can see that our accuracy increased. It went from 99.4 to 99.9. So now you can see that it is a much better fit, and it is following all the way along, except for this area here and a little bit of area over here. So this is basically the idea of polynomial regression. So if we wanted to do linear, we can do that as well. We can simply write 1 degree because linear equation is also part of polynomial equations. So if we run this, and there you go. So this is your linear fit, and you can see that the accuracy now is really bad. In this case, you can see that we have lots of gaps everywhere if we use linear equation. But if we add just 1 degree to it, you will see that it gets better. And if we add 3 degrees, you saw that it even gets better. Let's try it with 4. So here you can see it's getting even better, 9.925. But the question is, where do you stop? The thing is, we are not really using testing data, we are using the training data again. So we have to be a little bit careful because we might actually overfit the model. So we don't want to do that. And that is not good enough because it won't be able to give good predictions for new data or the predictions for future. So next what we can do is we can ask our model to predict what will be the cases, the number of cases after 2 days or after 5 days or after 10 days. So the data we have does not include the past 2 days, and we already know what are the total number of cases up till now. So what we can do is we can use this model to predict the next 2 days and see how accurate that is. So if we go here and we can create a new section, and we can call this prediction, and here we are going to write how many days do we want the prediction for. So in this case we want 2, and then we are going to print this. We will call this prediction, and here we are going to print that our prediction is basically prediction. We will say that cases after whatever many days we have specified is basically we will calculate in the next line. So we will say that this does not have an end, and over here we are going to print again, and we will say that model.predict, and what we will do is we want to predict the number of days. So if we go back here to our cases, and we have the values till 234, so this is the day number 234. So we want the prediction for after 2 days, so we have to add 2 over here. So we will write here 234 plus whatever days we have specified, and this has to be in 2 square brackets. This is the format that is required for the prediction. And the thing is that as you know, we have to create features of our X before we can send it. If you remember here, where is it? Here we created these poly features of our X. So again, if we want to predict, we have to create these features again. So we will copy this, and we will create the features of this number. So we will put another bracket, and once we get the value, we have the prediction value, we will divide it by 1 million because we want the value to be in millions. How many zeros did I put? One more. And then we are going to round this off so that we get a good number. So we will round it, let's say to 2 decimal places, and then in front of it we can write million. So here we will write million, and yeah, that should do it. Now if we wanted to plot as well, we could do that, but let's see the prediction first. So let's run this, and if we close this, does not define a round method, so probably a mistake maybe in, okay, so I think the mistake is here. This bracket should be here. So if we run it again, and if we close it, okay, again we have the same thing. Okay, let me try to change this to integer first. So we will have it here, and then we can close it here. Let's try that. Okay, that worked. So our prediction is basically 23.1 million, and if we go to today's cases, you can see that it is 23.1 million, so which is quite accurate. But again, if we try different values, we can try 5, let's say, and that gives us, let's close this, that gives us 24.01 million. If we give it 30 more days, let's see what it tells us after 1 month, and that gives us 32 million. Oh my god, so that's a lot. I hope it doesn't go to that. Okay, so what we can do next is basically we can plot this so we can see the trend on the graph as well. So we can write here that our x1 is basically, now we are creating new x values, so we want to plot from 0 till, let's say, whatever the end of days is. So here we have 234 plus the number of days, so in this case it's 30, so we want till that value. So we will call this as numpy array, and inside this numpy array we are going to say that we want a range, and the range should be from 1 to 234 plus whatever the days we have, and this should be a list. And we do have to reshape it. If you remember, we reshaped it before sending it in, so we have to do this. So if you remember here, we were reshaping this whenever we are creating the numpy array. So this is what we are doing here. And then we are going to create our y values. So let's call this y1, and we will say again model.predict as we did before, and again we have to use the transform, fit transform, because the feature needs to be extracted or calculated. So we will write here x1, and then we can write here plt.plot, and we want to plot y1, and let's give this a red color with a dash line, and let's bring these two down. Wait, this is blue. Okay, yeah, let's bring this down and let's run it. And there we have it. So the purple line here is the actual data, and then the dashed blue line is the best fit curve that the polynomial regression found, and then the red part here is basically the prediction of the future. So what will be the cases and what seems to be the trend. So this is what we can see here. Now again, if we put a small value, you will see a small change. So if we put 5, there you go. So you are looking at a shorter graph. So this is how you can basically fit a non-linear data set, and this is a very quick and easy method to do this. Now there's a lot of situations where you have non-linear relationships, and there you can use polynomial regression, which is quite useful, and as you can see the prediction is quite good. So this is it for today's video. I hope you have learned something new, and I truly hope that the predictions that we got here today are not accurate, and the cases, hopefully they will suddenly drop down and the coronavirus will finally vanish. So if you like the video, give it a thumbs up and stay safe, and I will see you in the next one.